Let's continue looking at sign charts. We've already seen how to solve inequalities using a sign chart. We're going to continue with that, but also I want to show you how to use a sign chart to come up with the graph of a function. If we wanted to solve the inequality 2x plus 42 is less than 0, I know that you could do this algebraically, but if we want to do this using a sign chart, the very first thing that we should do is factor it completely. So to do that, I'm going to factor out the negative 2, and we'll be left with x minus 21 is less than 0. Then we're going to use a sign chart to help us solve it. Now, remember, with creating a sign chart, we need to identify all of the zeros, and in this case, there's only one. That'd be 21. That will make the function equal to 0. Then we have to test each interval. So I pick a number that's smaller than 21. Maybe I pick 0. And I plug it in there, and negative 2 is always going to be negative. And 0 minus 21, that's negative as well. So we're taking a negative number times a negative number, which is going to be a positive number. So we identify that with a plus. Then we do the same thing on the other side, and we pick any number out here, and it doesn't matter which one, so I'm going to take a billion. And if we take a billion, negative 2 times a billion minus 21, well, negative 2 is always negative, and a billion minus 21 is going to be positive. So negative times positive will be negative. Now we can go back and answer the question, when is that inequality going to be less than 0? It's going to happen when it's negative. So that would be when x is greater than 21. If we have multiple factors, then we have multiple zeros. And so we identify them on our number line. The first 0 from x plus 5 would be a 0 of negative 5. And from x minus 4 is going to be positive 4. Both of these are going to make the expression equal to 0. So I'm going to use a dot to signal that. Then we go back and test each interval. So I pick a number that's very negative, like negative a billion. Negative a billion plus 5 is negative. Negative a billion minus 4 is negative. So negative times negative would leave us with a positive number. Then pick something in between the two, like 0. 0 plus 5 is now positive. And 0 minus 4 stays negative. One thing I want to point out, I hope you're noticing this, that as I passed over from the left side of negative 5 to the right side of negative 5, did you notice that the factor that changed was the factor that gave us that negative 5 as a 0? That is not by accident. That product overall will be negative. And now as we pass over that positive 4, I want you to notice that we pick a number out here like a billion. A billion plus 5 stays positive. But a billion minus 4 switches from negative to positive, making that entire product positive. Now we can go back and answer our question, when is the product less than 0? When it's negative. So when x is in between 0 or negative 5 and 4. Now how about x plus 2 squared? This is the first time that we've dealt with a squared factor, but we know that squared means x plus 2 times x plus 2. And the only 0 that comes out of that is going to be negative 2. And it will make the function equal to 0. Now, when we pick a number that's smaller than negative 2, negative a billion plus 2 is negative. Negative a billion plus 2 is negative. So the entire product is going to be positive. Notice now, as we pass over this negative 2, what happens to our factors? Well, every factor that gave us that 0 changes from negative to positive. So x plus 2 is now positive, and x plus 2 is now positive. So overall, the product is positive. So when we go back to answer the question, when is x plus 2 squared less than 0, there's actually no solution. which makes sense because we know that when we square something, we should get something positive. I want to take a look at or how we would answer some similar questions like x plus 2 squared being greater than or equal to 0. That's what we know squares to be, is that they're always positive, and even if we square 0, we get 0. So that would include all real numbers, right? The left side of the number line, the right side of the number line, as well as -2 itself. If the question were to ask, what is x plus 2 squared greater than 0, not equal to, then you have to break it up into two inequalities. You would have to say that x is less than -2, or x is greater than -2. I suppose another way you could write it is x is going to be all real numbers except x cannot equal -2. Ooh, here's the first time that we have a fraction. X plus 5 over x minus 3. When is this thing going to be less than 0? Well, we identify, I don't want to call them zeros now, I want to call them the most important points on our number line. All right, and here we're going to have two of them. The first one is going to come from the numerator, that being -5. The second important point comes from the denominator, 3. When we use -5, if x were to equal -5, then the entire fraction would equal 0. So I'll use a dot for that. But if we were to let x be 3, that would leave us with a fraction that's undefined because the denominator would be 0. So I'm going to signal that with an open circle. Then we go through our process just like we did before. Pick a number that's very small, like -1 billion. -1 billion plus 5 is negative. -1 billion minus 3 is negative. Negative divided by negative is positive. As I pass over -5, and we test a point that's in between here, like 0, 0 plus 5 now becomes positive. 0 minus 3 remains negative. Positive divided by negative is negative. Then, as we pass over that 3, x plus 5 stays positive. Like, pick a number like 1 billion. 1 billion plus 5 stays positive. Billion minus 3 turns into being a positive number. Positive divided by positive is positive. Then, when is this fraction less than 0? Well, when it's negative. So when x is in between -5 and 3. A similar fraction, 3 minus x over x plus 8 being less than or equal to 0. We should factor this completely before we get started. It maybe looks like it's factored, but it isn't factored completely because all the leading coefficients need to be factored out. And in our numerator, we can factor out a -1. Then we'll have x minus 3. Our denominator is factored completely, x plus 8. Now, we identify our most important numbers. This 1 does not give us a 0, but x minus 3 does. That gives us a 0 of 3. And x plus 8 gives us a 0 of -8. -8 will make the fraction undefined, whereas 3 would make the fraction equal to 0. So now, test each interval. Pick a number that's very negative, like -1 billion. Well, -1 is always going to be negative. That one's not going to change. But -1 billion minus 3, that's negative. -1 billion plus 8 is negative. Negative times negative would make positive number in the numerator. Divided by a negative number makes it negative again. Now, as we pass over -8, we know that the factor that's in the denominator will change from negative to positive. And we go through the process again. In the numerator, negative times negative is positive. Divided by a positive leaves us with something positive. And as we pass over that 3, it's x minus 3 that changes from negative to positive. Overall, this fraction will be negative. So now, answer the question. When is this fraction going to be less than or equal to 0? Well, when it's negative in these two places. Notice that on the first interval, x being less than -8, we cannot equal -8 because that would make our fraction undefined. But on the other side, for x being greater than 3, we are allowed to equal 3 because that would make the fraction equal to 0. For this last one, I want to switch it up from solving an inequality to look at how we can use a sign chart to help us come up with a graph. Y equals x times x plus 4 times x minus 2 is going to be a polynomial. So we know polynomials are smooth, they're continuous, they're real nice. When it's completely factored like this, we can identify our 3 most important points as being -4 and 0 and +2. All 3 of these are zeros, so they will make the function equal to 0. Then we're going to go through the whole process of a sign chart. Pick something extraordinarily negative, like negative, I don't know, a billion. Negative a billion's negative, negative a billion plus 4 is negative, negative a billion minus 2 is negative. The entire product is negative. As we pass over that -4, it is x plus 4 that changes to positive, and the entire product becomes positive. As we pass over 0, it's x that changes from negative to positive, and the entire product becomes negative again. Then finally, as we pass over 2, it's x minus 2 that becomes positive, and the entire product is positive. This is enough to give us a reasonable sketch of what our graph would look like. I know that when x is less than -4, the y value is negative, which means that it has to be below the x-axis. In between -4 and 0, it's going to be positive. At 4 and at 0, the y-coordinate is 0. So these points are x-intercepts. I know that this function's continuous, so I have to be able to connect those 2 points to be able to get from -4 to 0, but staying on the positive side of the x-axis. Similarly, from 0 to 2, our y-coordinate is negative, so we're going to be underneath the x-axis. And then beyond 2, our y-coordinate is positive, so it's going to stay above the x-axis. Now, this isn't an extraordinarily accurate graph, but it is a good sketch of a graph. It gives us an idea of what this function will look like without all the details of exactly how high the maximums and minimums are. But that's how you can use a sign chart to come up with a sketch of a graph.